So we are looking at the paper Jan 24, and we are looking at the last question of Jan 24, and we will do it now. So here it says x equals sec x and y equals some tan x, and the first bit says just find the the differential dy by dx in terms of t. Now that is as usual, so we are going to say dy by dt, so we are going to say dy by dt divided by dx by dt. Now dy by dt, my y is root 3 tan of t plus pi by 3, and my dy by dt will be equal to root 3 sec square t plus pi by 3, and my dx over dt. Now sec t is actually the differential of sec is sec x tan x, so sec t tan t. If we divide it, you are going to get it as root 3 sec square t plus pi by 3 over sec t tan t. You cannot do anything to this because they are asking you for the answer in terms of t, so this is the answer for part A. Let's look at part B now. Find the equation of the tangent at the point t equals pi over 3, and we are looking at t equals pi over 3 now. I'm going to clear this. So at t equals pi over 3, so at t equals pi over 3, your x would come out to be 2 and your y would come out to be negative 3. So we know this point, and we are looking at the equation of the tangent at this point. We know dy by dx has been given, we found out in the previous part, and if you plug in t equals pi by 3 in there, you will get the gradient as 2. If you plug it in correctly, remember when you're plugging sec, you have to plug it in as cos, so make sure that you plug it in correctly and you put in y equals 2x plus some c that's passing through this, and once you make the equation properly, it's going to come out as 2x minus 7. So that will be your answer for part B. For part C, it requires a little bit of manipulation. So we are saying that show that all points on C satisfy this equation, which means we are looking at the Cartesian equation of this particular equation. So from what I can see as y, so y is a tan addition rule there, so you might want to look at your formulas there. So this is tan t plus pi by 3. Let's open this up. So tan a plus tan b, root 3 remains here. Tan a plus tan b is tan a plus tan b, and then it'll be 1 minus tan a tan b. Okay, so now when you actually open, let's keep it like that, and then we go on to see what we can do with the x. So x equals sec t. We know there's a relation between sec and tan. If I square this, I get sec square t, and 1 plus tan square t is actually sec square t. So there you go, and then 1 minus x square will be tan square t, x square minus 1. X square minus 1 will be tan square t. So we write it down. So x square minus 1, and the root of x square minus 1 will be tan t. We are going to use that in there in a bit. So if we plug in tan pi by 3 in there, you are going to get, so if you plug in tan, we say pi by 3, tan of pi by 3 equals root 3. So we are going to plug it in there now, and it is going to become this. So I'm going to plug in everything in there so that we get it in a form. So my y equals root 3. I'm going to take tan t and plug it as roots of x square minus 1, and then tan pi by 3 is square root 3, and then at the denominator I have 1 minus x square minus 1 times root 3. Now be very careful as you work with this. So we are going to now start manipulating this to get this answer here. So we are actually getting it in this format. Okay, now my y could be written as, I'm going to open up the bracket here. It could be written as, you can multiply the 3 inside. So it becomes 3x square minus 3, and this becomes plus 3. Root 3 times root 3. This becomes minus 3x square minus 3. Now from the denominator here, what I'm trying to show, I can see that they have actually rationalized the denominator. So I'm going to rationalize this denominator, and when I rationalize, I'm going to multiply it by 1 plus 3x square minus 3, and then here also 1 plus 3x square minus 3. Now when you open this up, we're going to slowly open it. So each term, so that will be square root of 3x square minus 3, and then plus 3x square minus 3, because root times root will cancel out the roots, and then you have a plus 3, and then you have plus 3 times 3x square minus 3. Okay, I'm going to go and look what we are trying to prove. So we are kind of getting there, and in the denominator it'll be 1 square, which is minus, and be minus 3x square minus 3. Yeah, so then you can cancel these out. It'll be 3x squared plus 4 square root of 3x square minus 3 over, when I open this up, this is going to be 4 minus 3x squared equals y, and that is our final answer. So I've manipulated this, and you get exactly what you're looking for here on the top. So it's ax square plus b times 3x square minus 3, and there we go, 4 minus 3x squared. That's your final answer.